Hello. After discussing design patterns for last few weeks, today we are going to discuss one architecture, that is microservice architecture. Okay, let us see what is microservice architecture, what are the benefits, and how we can use it. So if I define what is Microservice architecture is, it is a design approach where a system is composed of small independent services that are communicated over well-defined APIs. Now, when it comes to microservice architecture, you will have in the whole system, you will have subcomponents. And importantly, they are independent from each other. They are loosely coupled through the well-defined APIs, but they are independent from others. So the goal of these microservices are to improve the scalability, in the sense, in case there are a large number of users that are growing in future, you can easily scale it. And in case of maintainability, you can upscale or horizontally scale these servers, and you have the deployment flexibility where you can target the specific microservice and do your deployments independent to others. When it comes to maintenance, you can do all the maintenance for a given microservice without impacting others. Right. So let's go back to the monolithic application, which are the standard. In this monolith application, uh, so they are single applications which are server-side application. All components are running together, probably one database, one application server, so on and so forth. You can argue that, yes, it is easy to manage. Yes, in the early days of applications, when you don't have large number of users, when you don't have many features, of course, it is easy to manage. But it's highly dependent. In case there is a failure, entire system will fail. In case you do a wrong release, you do a misrelease, entire system will fail, which runs into single point of failure. And also, because of this monolithical nature, you have to depend on one database, one framework, one development language. Now, for example, let's say you want to use multiple databases. For transactional purposes, you need the transactional database, and for the other purposes, documentation purpose, you need the MongoDB database, which is very difficult to utilize. Scalability. Now, in case of monolithic applications, you can do the vertical scaling only. You can't do horizontal scaling, in the sense you can increase the memory, you can increase the CPU, but there is a limit. Now, with all these challenges, people are looking at different approaches. So these are a couple of examples that I found. Now, when it comes to plantation, you can distribute your plantation application into small, scalable services like this. So materials will be in one service, logistic will be in one service, finance will be in one service, and MIS will be in one service. Now, in this particular example, MIS is mostly a reporting application. So you can integrate large number of reporting there, which are independent of others. So again, for an organization, you can look at different types of tasks that they have. Just think, what if you run all this in a standard, typical monolithic application? You run everything in one application, which is very difficult to do. So nowadays, what you do is you will distribute your application into multiple small scalable services. You may have realized there are applications like ERP solutions. They have purchasing, manufacturing, finance, HR, HRM, customer CRMs, dashboards, reporting. So they are different applications, but they are connected. One of the very important thing is how do you distribute these microservices? LMS, which we all are familiar with. So if you look at LMS, you can divide LMS into different services like as shown in this diagram. So if you look at in the monolithic architecture, your UI, business logic, data access layer all are in one. When it comes to microservice architecture, end user do not feel that they are in multiple systems. So it's a one UI, sorry. It's a one UI. And from the one UI, they are connected to microservice. And each microservice may have, it might not have as well, it may have separate database instance. But the nice thing is, end users do not feel that they are connected to multiple servers. If I go back to the previous slide, now for example, if a user wants to do a user service and do a enrollment service, he might be doing both of these using the same application, same UI, but it runs into two different microservices. So in microservice, every app is an own service. It can own its own hardware. For example, if you are running a large scale microservice, it might need large scale memory or CPU, so on and so forth. And it communicates via APIs, message queues, or the service brokers can be used. Normally it's APIs. If you want to have a synchronous communication between these services, you can go for message queues as well. You can have scaling. In this, with the microservice, you are having the both scaling. You have the horizontal scaling as well as the vertical scaling as well. In case of a change, you are only affecting one service, not the entire other thing. And this is very good with the agile development. You know, when it comes to agile development, one of the important tasks is you divide your task into smaller tasks. With the microservice architecture, you can easily divide your task into smaller tasks. So how it happens is, client connects to the API gateway. API gateway will connect to multiple services. In some cases, services may connect to the other services. Point-to-point connection can happen, but typically it goes through the main API gateway. Like design patterns, microservice also has some relevant design patterns. So these are the very common design pattern. API gateway pattern, central entry point for clients, and it's handle the routing and authentication and rate limiting. So when the user hits the UI, it will navigate to the relevant services through the API. Service circuit breaker pattern. Now, in case of a failure, it doesn't cascade the failure to the other services. It will stop calling to failing service until it will be succeeded. Service discovery pattern. It's automatically detect the services in the dynamic environment. Depending on the user needs, it will detect what this user need is and it will direct to the relevant service. Database per service the service pattern. In this one, microservice will have its own database to ensure loose coupling. Now, there are challenges with this. So for example, there are master data. For example, custom is a master data. If the both system wants to integrate between master data, what are your challenges? Then you will have something called master data management. I will let you to find what the master data management is. Saga pattern. manages distributed transactions using sequence of local transactions. Remember, we discussed during one of the design patterns, uh, adapt a design pattern, how you can connect to multiple services. So in that, we had a challenge of distributed transactions. So the Saga pattern will identify the manage the distribution transaction through local transactions. Then the CQRS, Common Query Responsibility Segregation, it separates read and writes operation for scalability. So typically, when it's so normally what happens here is reporting part will be a separate microservice. So in the next semester, we are learning about data warehousing. So you can consider it as a CQRS design pattern where all your reporting stuff will be directed to a separate instance, and it has a separate design as well. Right. Monitoring and observability. So typically you need to have central logs. You will have multiple services, but you need to have a central uh, auditing mechanism, logging mechanism to identify which were connected and which were didn't connect, what are the issues had, what are the messaging issues, so on and so forth. Tracing, when it comes to troubleshooting, you need to do the distributed tracing. This event occurs on this service and it will transfer to the other service through the API call or message queue, and what has happened to that microservice. Important, these matrices should be identified by the probable UI interfaces, reporting interfaces. Typically, people use Prometheus and Grafana as the interfaces or the matrices for uh, monitoring and observability in microservice design pattern. Now, another challenge is testing these microservices. Now, remember, unlike the monolithic applications, in this one, your services are distributed. Now, important thing is you can do the unit testing. You can individually test for that particular microservice. Then you have to do the contract testing. That is, you are contracting uh, one service to the other through the APIs. You have to test the APIs. Then the integration services. When you are integrating between two services, let's say you have enrolled and then the exams are done. So those are two different services. So integration testing should be done. And finally, end-to-end testing, entire workflows for the validation should be done. So microservices are small in nature and they are loosely coupled. A single small team of developers can write and maintain service. So agile development, as I said before, you can allocate one team for one microservice. Where entire one architect will be looking at the entire service. Remember, even you have the agile platform, you can couple agile platform. There should be an architect and a tech lead who are looking at the entire service, including the QA lead as well. They can run in isolation, but there are some set of people who need to look at the holistic view of all these services. Otherwise, what will happen? You will develop your services separately. When it comes to integrations, there can be issues. Uh, each service should have a separate code base which can be managed by the development team. The service can be deployed independently. Team can update an existing service without rebuilding or redeploy the entire application. Now, every service should have its own roles and responsibilities. What are its boundaries? When you are communicating between services, it should be done through the well-defined APIs. Ideally, we should not call cross-database queries. From one database should not call another database. So there are, and these services can have its own technologies. As I said before, it can have its own operating system if needed, and it can have its own database, it can have its own architecture, it can have its own configuration. that doesn't have issue with others. So that to happen, you should be communicating through APIs. Okay, so I'll be leaving the reflective questions. How does the principle of loose coupling in microservice influence system scalability and teams autonomy? Autonomy is it can work on its own. In what scenarios might a monolithic architecture be more appropriate than the microservices, despite the benefits of modularity? So remember, uh, your microservice has its own benefits, but you need to understand it might not be the solution for all the problems. And third one, how do microservice design pattern, which we have discussed, help address the challenges introduced by the distributed systems? So basically, it's a distributed system when you have multiple microservice. So then how this design pattern can help us to address the challenges that are introduced by the distributed systems. So during the weekly discussions today, which are going to happen, what we are looking at is we'll be looking at 6 different platforms. 6 different platforms, and so I have listed out the domain and the key services that it involves, and also main challenges. So just get an idea about these domains, and then we will discuss what are these services and what are they offer, and how we can use microservice architecture to get the best requirement out of this. So let's meet on the class and let's discuss this in more detail. Thank you very much.